What's up, everybody? Welcome to another video. Hope you're ready to flex those brain muscles. In this video, I'm going to talk about systems of nonlinear inequalities, and in particular, how to find the solutions to these systems, which is interesting because solutions to systems of inequalities we typically show graphically as a shaded region, like what's shown here. This is a solution to a system of three inequalities. So we're going to go through this process in this video. Hopefully this helped. It'll be timestamped, skip around, use it in the way that is most helpful for you. This is the first type of example we're going to go through, which is just graphing a solution to a system of inequalities. So hopefully you've dealt with systems of equations. Now we're dealing with inequalities. How is this different? Well, let's talk about what does it mean to be a solution to this system of inequalities. So since this is the first example, a solution to this system, since we have two variables here, is an ordered pair, A, B, that satisfies both inequalities, right? That makes each of them true. So here's an example, 1, 1. This is a solution to this system. Why? Because when I replace x with 1 and y with 1, each of these inequalities become true statements. That's what we mean when we say satisfies each inequality. So 1 plus 1 is 2, and 2 is in fact greater than 1. And 1 squared plus 1 squared is 2, and 2 is in fact less than or equal to 9. So 1, 1 is a solution to this system of inequalities. But again, the best way to show these solutions to a system of inequalities is graphically. And this is a little bit tricky, but here's how we're going to do it. First, we're going to take each of these equations and we're going to sketch the graph of them. So for this first one, I'm going to rewrite it as an equation. And since I notice that it's linear, we have x and y, each to the first power, I'm going to write it first like this. Y is greater than negative x plus 1. I've subtracted x from both sides of the inequality, right? Now what I'm going to do when I graph this, because this is often confusing for students to think about, what does it mean to graph an inequality? The greater than, this is weird. So now what I can do is I can say, okay, well let me just graph this. So maybe off to the side I'll write this. What if I replace the inequality with an equals? Then all of a sudden this becomes a lot more clear on how to graph this. So I'm going to graph this y equals negative x plus 1, which hopefully we can comfortably do. And I'm going to do this in red. So I have a slope of negative 1, y-intercept of positive 1. So I would call this slope-intercept form. So I'm going to plot the y-intercept. I'm going to use the slope to go down 1, right 1, and just plot a few points here. And now before I just draw my line, I want to think about the inequality and what it is. In this case, we have greater than. This is another way to say this is strictly greater than, right? It doesn't include the or equal to like this less than or equal to does. So because of that, what I'm going to do is instead of drawing a line all the way through these points, I'm going to make this a dotted line. And I'll make this a little bit more clear here in a second for why we do this. So I'm going to write a dotted line here, this diagonal dotted line, and this goes on forever, so I can still do an arrow in each direction. And now why is it that we do this? Well, because points that are on this line we know are not going to satisfy this inequality, because points that are on the line, right, those points, the left and right hand sides of the inequality equal each other, because we just graphed y equals negative x plus 1. But if both of these sides are equal, then we know it's not a solution to this inequality, because this inequality wants the left-hand side to be greater than the right-hand side. So we include the dotted line to say, hey, points on this line are not solutions to this inequality. And now what we do is we look at the direction of the inequality to tell us whether we shade above or below this line. Since it says y is greater than negative x plus 1, we shade above. So I'm going to show that shading with just some arrows going up instead of just doing scribbles. So I'm going to do arrows going up. Y is greater than negative x plus 1. And if you're thinking about, can I check this? Right? Can I make sure that I shaded this correctly? Well, you can pick any point that's within this region and plug it into that first inequality, and it should make it true. Right? So an example is what? Let's try 1, 1. We can try that again. We see 1, 1 in our region here. And we've already confirmed that that does work, and you can do that for a few points. Awesome. Let's do our second graph here. This hopefully recognizes a circle. I'm going to do this one in purple. This is a circle. It's centered at the origin and it has a radius of 3, right? Remember the general form of a circle. I'll write it off to the side. X minus h squared plus y minus k squared equals r squared. So what do we square to get 9? That's 3, so that's the radius. And we can think of h and k in this case each being 0. Might be a little tricky to see that, but we have a circle here. So what are we actually going to graph? Well, let's first just graph this. X squared plus y squared equals 9. That should be easy to graph. And in this case, I don't need a dotted line. I can use a solid line because look at our inequality. It is not a strictly greater than or strictly less than. We are including the or equal to part, which means all the points on the curve are going to be, in this case, solutions to the inequality, unlike the last example. So let's go ahead and graph this. Let's put a point here. I'm just going to start at a center of 0, 0. I'm going to go 3 to the left, 3 up, 1, 2, 3 to the right, and 3 down. And I'm going to try my best to draw a circle here. Okay, there we go. Circle, circle. All right, and I can draw a solid line because, again, less than or equal to. Now, what does this mean, less than or equal to? Because this is different. There is not really a above or below in this case because we have a closed shape here. Instead, there's an inside and an outside. So whenever we have closed shapes like this, they're typically going to be circles, right? Whenever we have closed shape like this, the less than or equal to means we shade inside, greater than or equal to means we shade outside. So in this case, we are going to shade inside the circle. So let me do my shading here. I'll just draw a few lines to show the shading. All of the points that are either on or inside the circle are satisfy the inequality, right? Are solutions to this inequality. So now we're looking at a system. So we want to figure out where do these two shaded regions intersect because that's going to be our solution. So I see here we have this dotted line and we shaded above and then we shaded inside the circle. So in blue here I'll do where they both intersect. And that's here, above the dotted line but inside the circle. Above the dotted line but inside the circle. And this is going to be how we're going to show the solution to this system of inequalities. First, we're going to graph them each, and if it helps to think about them using equal signs to graph them, that's perfectly fine. We just have to make sure we do the correct either dotted line or solid line and do the correct shading, above, below, inside, outside. Then we just look, where do these two shaded regions intersect? And then we shade that in, and that is our final solution. And we do see that, in fact, 1, 1 is inside that shaded region, which is good. If it wasn't, there would be some kind of mistake, because we already said 1, 1 was a solution to the system. Awesome. Let's make this harder. Let's try an example where we have 3 inequalities. So again, I'm going to do the same exact thing. I'm going to graph each of these. I'm going to make sure I pay attention to the inequality and do the correct shading, dotted solid line, that sort of thing, and see where all 3 of these shaded regions intersect. So when I'm doing each of these shaded regions, I'm graphing the solution set to each individual inequality, and where they all 3 intersect is the solution to the system. Alright, so first I'm going to do some tricky algebra here because I really want this as y equals mx plus b. So what am I going to do to this? Let's see, there's a couple ways I can do it. I can subtract x from both sides. This is really tricky. We got to pay attention here. If I subtract x from both sides, now do we remember what happens when I divide both sides or multiply both sides by -1 to make this y, not negative y? We had to flip the inequality. So that's why I like showing this example, because we have to make sure we remember these rules when we're manipulating inequalities. So let me draw a little arrow here. Finally, what we have is y, positive y, is greater than or equal to positive x plus 1. So off to the side, this is the actual line we're going to graph, and we are going to graph a line because it's less than or equal to. And it's going to be y equals x plus 1. Super easy to graph, slope of 1, y-intercept of 1. So I'm going to go over here and go ahead and do that. There's my y-intercept of 1. I go over 1, up 1, over 1, up 1. If I go left 1, I can go down 1, right? Hopefully we're pretty comfortable with graphing lines at this point. And I'm just going to draw a line through, again, a solid line because we're including the or equal to part in our solution. And now do I want to shade above or below? Well, again, we look at the final form that we manipulated our inequality into, which is here, and that says y is greater than or equal to x plus 1. So greater than or equal to means we shade above. So I'm going to draw some arrows here, shade above. We are shading above this line. So here is the solution set to this individual inequality. Now let's move on to our second one. And this is already in a nice form. We don't need to manipulate it at all. Y less than 2x squared. This is a quadratic. It has a vertex at the origin at 0, 0. And it is stretched by a factor of 2. So if you're pretty proficient with like transformations, this should be pretty easy to graph. I'm going to go ahead and do it in red. So I'll just make a little red star here to say, hey, this is the red one. And again, what I'm graphing here is y equals 2x squared, but I am doing a dotted line because we do not include the or equal to part. So I'm going to do a point here at the origin in red, and instead of going right one up one, like the parent function would do, I'm going to go right one up 2, right? Because we are stretched by 2, 2x squared. And I'm going to go left one up 2, and this should be enough points. I'm comfortable with 3 points. I know the shape of this thing. Oop, and I did what I said I shouldn't do, which is what? I drew a line. I really need a dotted line here. So a couple of dots. The dotted lines are kind of hard for me to draw on here. That's okay. Dotted line. Or dotted curve, rather. I guess I should say. Dotted curve. Awesome. All right. Now, where are we shading? Y is less than 2x squared. So less than means I did my dotted line. And again, because it's less than, I'm thinking below this curve. It's kind of weird to think about below when the curve is so like steep, but all of this stuff down here is below. If I draw this arrow down, 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 down. So I'm already seeing some intersection between these two shaded regions. And let me just show it real quick, and then I will erase it. But here, there's some intersection, all of that stuff, right? Above the line, below the curve. And here, a lot of this stuff, right? So I'm already seeing some intersection, but we still have to draw what looks like a circle. And so let's see, I've got red, purple, so now I can do blue. I'll do blue for our circle here. This is a circle, this time with a radius of 4, but still centered at the origin. So I'm going to go through and I'm going to go 4 away from the origin to the right, below, to the left, 1, 2, 3, 4. And above, 1, 2, 3, 4. And I'm going to do a solid curve because, again, less than or equal to. So solid curve, and this is going to be a very ugly circle. That's okay. Solid curve. Curve. All right, connecting the stuff, shading inside, again, inside the circle. And this time I'm just going to go ahead and, well, I guess I can shade inside, but it is getting a little chaotic here, and I really want to think about what is my final solution. But I'll do a couple of lines in here just to show, hey, I'm shading inside. All right, where do these 3 shaded regions intersect? It's a little bit more chaotic with 3, but let's think about it. Below the dotted curve of the parabola, above the solid line, y equals x plus 1, and inside the circle. So I think we sort of have 2 regions here. In here, I'm going to do these in white. Hopefully you see that. Below the curve, inside the circle, above the line. And it looks like a tiny little section in here where it's below the curve, inside the circle, and above the line. So this is kind of an interesting example. You typically don't see like 2 sort of disconnected sections that form the solution to the system. But this is in fact it, these 2 little sections, because these are the intersection of all 3 of the shaded regions. Hopefully that's making sense. Let's do one last example here. Y is greater than x minus 4. And again, I'm going to go ahead and do this in purple, and it's already written in perfect form to where off to the side I can write y equals x minus 4 and just make sure I do a dotted line and shade above. So I'm going to go down to minus 4 here because that's the y-intercept. And I'm going to go over to 1, 2, 3, 4 and plot another point here because I know the slope is 1. And so I am doing a dotted line. So a dotted line between these. And I know that I want to shade above this dotted line. So I'll just draw a few arrows up to indicate that I want to be shading above. And that is a good starting point here. Awesome. All right, y is less than or equal to negative 3x squared. So again, I could draw a solid line here because less than or equal to. And I need to graph this, negative 3x squared. This is a nice example, another quadratic. This time it opens down, right? It's reflected, and it's stretched by 3. And if you have no idea what these things mean, if you're not up to date on your graphing stuff, just plot a few points. Plug in 0, plug in -1, plug in 1, plot those exact points, right? But I'm going to go ahead and do it this way. I know we have a vertex at the origin at 0, 0. And I know that I can go left 1, down 1, 2, 3. And right 1, down 1, 2, 3. And I know that I can do that because I know it's reflected, it's opening down instead of up, and it's stretched by 3. Am I doing a dotted or solid line here? It looks like solid. Awesome. All right, so solid line through here, or curve rather. Solid curve to make my U-shaped parabola. And boom, there we go. Now where am I shading? Less than or equal to, so below. So I am shading all of this stuff below. Let me draw some arrows here. This stuff in here, this skinny little part, it kind of looks like, again, that it's inside, but I like to refer to it as below, less than or equal to. Okay, now we got a circle. See, what color do I have left? Blue. Blue circle, same exact circle as before in terms of center, origin, radius 4, but this time let's notice this inequality. This is interesting. 1, 2, 3, 4. All right, go up here. 1, 2, 3, 4. This way. 1, 2, 3, 4. Down. All right, we can do a solid line, again, greater than or equal to. So we can do a solid line. It's a terrible looking circle. That's okay. All right, solid line, but again, greater than or equal to. What does that mean? That means, since we have a closed shape here and a greater than or equal to, we are shading outside the circle. This is the first example where we've done this, but I wanted to show examples. Everything outside the circle is a solution to this particular inequality. I'm shading all outside here. So now I can look at, where do these three things intersect? Greater than this dotted line, so above the dotted line, below or on the parabola, and outside of the circle. And I think if I graph this a little better, the answer would be a little bit clearer. What is this tiny little part in here? Tiny little part in here. If you spread out your graph a little bit more, it may be more clear. Hopefully you can see that. I just did it in white. I'll undo it and do it one more time. That tiny little part in here, that is above the dotted line, outside of the circle, and below the parabola. So that little tiny little part there. Hopefully this is making sense. Let's do a couple of like quiz style questions, some checks for understanding. Pause the video at this point, check out this system of inequalities, and select A, B, C, or D. Which of these graphs shows the solution to the following system? I'll give you 5 seconds. All right, let me talk through my thought process for how I think about this. So first I go to the first one here. I know we're going to have a dotted line, x plus 1. That's shown in all 4 of these, right? Dotted line. So if there was a solid, I could automatically eliminate that. And I know we are shading above the dotted line. So what can I get rid of here? This one, C. That shaded region is below. Can't be that. Above the dotted line. What else? A. A is gone. Can't be either of those, A or C. Hopefully that makes sense. Above the dotted line. So what are our possibilities? Like out here, in here, in here, here, here. Like any of these above the dotted line. So far, at least, just from our first inequality. The second one tells us what? Less than or equal to x squared. So we have this parabola here, x squared, and we want to shade below it. And it's also a solid curve, not dotted, which does check out. We want to shade below it. So that means we're going to be somewhere like out here and here, 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 here. And so from our choices left, only one of those is shaded below the parabola, and that is choice B. Choice D is shaded above. And finally, we could look at this third inequality, which is a circle, shading inside the circle, which all 4 of these were, so that didn't help us a whole lot. But let's check our answer one final time. Above the dotted line, below the parabola, and inside the circle. This is the shaded region that satisfies all 3 of those requirements. B. So hopefully you picked B. If you did, you are correct. Nice job. Let's try one more. I love these types of questions. I give you a bunch of points. I label them. Then I give you a little system here. This time we just have 2 inequalities. And I say, which of the following points are solutions to the system above? So I'll give you 5 seconds. Alright, so this might be a little bit hard to do on your own, since the best way to do it is to graph on the actual page that has all the points, but that's okay. I'll do this first one in purple. This is a circle, and it looks like this is our first circle we've had to draw where we have a dotted line. At least I'm not remembering another example. So circle, centered at the origin, radius of 3. So I'm going to draw that point there, that point there, that point there, and that point here. And let's do a dotted line or dotted curve that connects all of these and forms a somewhat decent looking circle. Alright, so I'm already seeing some of these points that are solutions to only the first inequality. Hopefully we all see why E is not. E is on the circle, and remember, that's the whole point of putting the dotted line, is to say that, hey, the stuff on the circle is not a solution, just the stuff inside. Okay, so far we have C, D, and G as possibilities. So let's graph this second inequality and shade it and see if we can narrow it down a little bit. So y is greater than or equal to negative 2x squared. Very similar to one we did earlier. This is a quadratic, it's a parabola, it opens down, it's stretched by 2, and it's greater than or equal to. So I'm using a solid curve here, no dots needed. So starting at the origin, boom, put a dot there. I'm going left 1 down 2, that's a point, and I'm going right 1 down 2, that's a point, and I'll draw a solid curve through there, solid curve through there. And now where am I shading? Well, from the first one I shaded inside the circle, right? So I guess I could have drawn some lines there. And from the second one I'm shading above this parabola, above. I don't know if we've done this before, where we've shaded above a parabola that's opened down. So since I'm shading above, I'll have lines going a different way. All of this stuff, and in fact going up forever, is technically like these are all solutions to this specific inequality, but to the system it's all the stuff that is both inside the circle and above or on the parabola. So in red, I'll go ahead and show the solution to the system. All of this stuff here. So we see C is a solution. And what else? I'm missing one that I just kind of covered up. Let me go back and see if I can show it. This letter here, D. This is on the vertex of the parabola, right? Which is okay because, again, greater than or equal to. So it can be on the parabola, and that's a solution to this particular inequality. It's also in the circle. So this D, that's the tricky one here. This is in the shaded region. D, we want to include that. We don't want to include E because that's on the circle. The circle is dotted, right? We don't want to include G down here because that's below the parabola. So C and D is the final answer. Those are the 2 points that are solutions to the system, and one more time I'll shade it. Awesome. Hopefully this video wasn't too long. I know drawing these graphs is sometimes a little bit messy. Hopefully you were able to follow some of the stuff. Leave any questions below. I'd love to answer questions. Hopefully this helped. Also like and subscribe, do all that stuff of course, but most importantly, keep flexing those brain muscles, and I'll see y'all later.